let's look at inelastic and elastic collisions. So in elastic collisions, kinetic energy is conserved. Right? No. Now this just means the kinetic energy initially is equal to the kinetic energy after. So the sum of those energies initially will be equal to the sum of those energies after the collision. Now we can just add the kinetic energy of the first object plus the second object before the collision plus the kinetic energy of the first object plus the second object after the collision. Those must be equal to each other. Now in inelastic collisions, kinetic energy is not conserved. Now this just means the sum of kinetic energy initially is not equal to the sum of kinetic energy after or finally. Now let's look at bouncing objects. Right, so if it's elastic, this is how you'll have the velocity versus time graph. Remember, the kinetic energy is the same, so we cannot lose any velocity there. Right, so if we try to draw a straight line there, you'll see that all these points line up because nothing is lost. Right, that's a velocity versus time graph there. Now this would be its displacement versus time, because nothing is lost. If it bounces to this point, even in the second bounce it will come back to the same point. Nothing is lost, everything is conserved. So that's just the displacement time graph of a bouncing object when the collision is elastic. Now if the collision is inelastic, this is what you would have. So the velocity decreases every single time. If you try to draw a straight line there, you'll see that it actually decreases. Every single time it decreases because now we are losing some energy. Kinetic energy is not conserved. Then let's look at its displacement versus time graph. That's what it would look like because we're losing energy. So the velocity becomes smaller and smaller. So if the velocity is smaller, the less distance traveled after every single bounce.